Next problem in difference of two proportion. A random sample of 100 men taken from a village, right, consuming alcohol, in another sample of 200 men. So village A, right, sample is 100, so n1, small n1 is 100, right. So second one 200 men in a second village B, so that is 200 n1, n2 is 200, right. 100 found to be consuming alcohol, right. So do the two villages differ significantly in respect of the proportion of men who consume alcohol? So n1 equal to 100, n2 is equal to 200. x1 be the number of person consuming alcohol in village A, that is they have given 60, right. In a random sample of 100 men taken from a village A, 60 were found to be consuming alcohol, so x1 equal to 60, and x2 be the number of person consuming alcohol from village B, that is 100. So out of 100 in village A, 60 are consuming, right. In village B, out of 200, 100 persons are consuming alcohol. So that is what the ratio. P1 is the sample proportion, right. It is proportion, right, consuming alcohol from village A. So P1 equal to x1 by n1, 60 by 100, that is equal to 0.6. P2 is the sample proportion of person consuming alcohol from the village B. P2 is equal to x2 by n2, that is equal to 100 by 200, that is equal to 0.5. So now we are going to define hypothesis. Null hypothesis, there is no significant difference. So there is no difference significantly with respect to the proportion of men who consume alcohol in the two villages, right. Alternate hypothesis, there is a significant difference. Let the level of significance will be 5%. Test statistics Z is equal to P1 minus P2 by root of PQ into 1 by N1 plus 1 by N2. So here they have not given capital P, so we are using the formula. P is equal to, capital P is equal to N1 P1 plus N2 P2 by N1 plus N2, or X1 plus X2 by N1 plus N2, right. So you can use the both formula. So we are using X1 plus X2, it is direct formula, 60 plus 100 by 100 plus 200, 0.5333. So Q is equal to 1 minus P, that is equal to 1 minus 0.5333, which is equal to 0.4667. So test statistics, substituting the values, 0.6 minus 0.5 divided by root of 0.5333 into 0.4667 into 1 by 100 plus 1 by 200. So you will get 1.6367. So calculated value of Z is equal to 1.6367. Tabulated value at 5% level, we know 1.96. So conclusion, calculated value is less than tabulated value, H0 is accepted. So there is no significant difference between the two villages. Next problem, in a random sample of 500 men from a particular district of UP, 300 are found to be smokers. In one of 1000 men from another districts, right, 550 are smokers. Do the data indicate that the two districts are significantly different with respect to the prevalence of smoking among men? Given sample size, first village n1 is equal to 500, second village n2 is equal to 1000. x1 be the number of persons smoking in the first district, right, that is 300. x2 be the number of smoking person in the second district, right, that is 550. So sample proportion P1 equal to x1 by n1, that is equal to 300 by 500, 0.6. P2 is the samples proportion from the second district. P2 is equal to x2 by n2, that is equal to 550 by 1000, that is equal to 0.55. Hypothesis defining, null hypothesis, there is no significant difference. Alternate hypothesis, there is a significant difference. Take the level of significance will be 5%. So test statistics is equal to, we know, right, P1 minus P2 by root of PQ into 1 by N1 plus 1 by N2, where P is equal to N1 P1 plus N2 P2 by N1 plus N2, or X1 plus X2 by N1 plus N2. So now we are going to find capital P. Substituting the values 300 plus 550 divided by 500 plus 1000, 0.5667. So Q is equal to 1 minus P, that is equal to 0.4333. So substituting the values in test statistics, 0.6 minus 0.5 by 55 divided by root of 0.5667 into 0.4333 into 1 by 500 plus 1 by 1000. So you will get 1.8423. So calculated value of Z is 1.84233, sorry, 1.8423, and tabulated value is 1.96. Comparing these two, so calculated value is less than tabulated, therefore H naught is accepted. So that means there is no significant difference. Thanks.